Algebra 2 students, happy first day to a new semester. I apologize in advance for this video. I've got Charlie with me. I'm in a dorm room and you guys are in a global issues class right now. We'll see what we can get through. We're going to start talking about quadratics. Quadratics are a type of polynomial equation. Quadratics are often referred to, it's the name we give to second degree polynomial equations. And we'll talk about all that too. And what a polynomial is as we get into it. But quadratics you might often know as ax squared plus bx plus c. That's a quadratic expression. A quadratic equation is anything where this equals a number, say 0. And then we have quadratic functions, and that's when instead of ax squared plus bx plus c equaling 0, we say f of x equals this, and then that would be a quadratic function. You may know that quadratic functions have a certain shape, and that shape is called a parabola, spelled parabola. That parabola can open up and it can open down, and it can be anywhere in the xy axis. And these values a, b, and c all play where that parabola goes. It tells you how wide it is, how narrow it might be, or where it might go. Other things about parabolas that are important is they have a vertical line of symmetry. That vertical line of symmetry goes through a special point on the parabola called the vertex. The vertex is the only point that does not have a mirror image over the line of symmetry. So vertex here. And the axis of symmetry. Notice everything else has a corresponding point aligned horizontally over that axis of symmetry. And we're going to use that symmetry when we graph quadratic functions, or I'm going to use it because it makes it easier. All parabolas come from a quadratic function, and what we are going to focus our study of quadratics on two things. First thing we're going to do with quadratics is how do you solve equations? And you may know the quadratic formula, but we're not going to be able to use that until we prove it. The other thing that we're going to talk about with quadratics is how do you graph quadratic equations. So we're going to solve them and we're going to graph them. We're going to solve them, we're going to graph. That's what we're going to do. Going to divide the unit into solving for the first part, graphing for the second part, and then a little potpourri of mixing them together. Lots of skills that you will use all through high school from this unit. This is a unit you want to do your best in. Obviously, that's true for every unit, but a lot of skills in this unit are skills you will need at least for the next 4 years as a high school student, potentially a lifetime if you are going to study mathematics. When it comes to solving quadratics, let's take a really easy example, and that's something like 4x squared equals 9. This is the easiest kind of quadratic to solve because there's no x term. So when I say quadratic, I want you to think ax squared plus bx plus c. Always thinking that there could be a squared term, a non-squared term, and a constant. The non-squared term causes problems. Well, you've solved equations like this all year, really. Think about, d equals 1/2 gt squared in physics and how we could solve for t. Notice there's no other variable t in here, which would make it a lot harder. So this is a quadratic in terms of t. So back to this equation, pretty easy. You solve this equation like you solve any other equation. First thing you do is you isolate the x squared. You multiply both sides by 1/4, and you get x squared equals 9 over 4. Now, interesting property about squaring numbers. You know that if you square a positive number, you get a positive number. And you know if you square a negative number, you also get a positive number. So both of these would be positive, whatever that number squared is. So when we solve an equation and we introduce a square root, we have to account for the fact that this number, x, that's being squared, could be positive or negative. So one of the things that you're going to have to start doing is putting in a plus minus term whenever you put in a square root. I can't stress that enough. Where did the square root come from? If it wasn't in the original problem and you put it in there, you better put a plus minus. The plus minus comes when you introduce the square root. When you put it into the equation. If it was already in the problem, if I told you x equaled the square root of 4, then the answer is x equals 2. But if I tell you x squared equals 4, then you have to put in the plus minus in front, and your answer is plus or minus 2. It's really that simple. Just ask yourself, did I put in a square root? If so, put in the plus minus. Now we go in and we simplify this radical, so you know what the square root of 9 is, that's 3, and you know the square root of 4 is 2. So the answer here is x equals plus or minus 3 halves. There are two solutions where 4x squared equals 9. One solution is positive 3 halves, the other solution is negative 3 halves. Spoiler alert, if you were graphing the function 4x squared minus 9, what you would see is the axis of symmetry going through here on the y-axis. This would be negative 3 halves, and this would be positive 3 halves. They would be equally spaced across that line. Here's the plus, here's the minus. Good? That's the easiest kind of solving a quadratic equation, when there is no squared term. It doesn't make it too difficult. You just isolate x squared, take the square root of both sides. Last semester, I got really concerned towards the end that kids were not fully watching the videos, or that if they were watching the videos, they had them on while they were doing something else. So I'm going to put in throughout the year this semester little tidbits of information as you're watching these videos, things that I need you to do to come in and let me know that you watched the video. So tomorrow, what I want you to do is when you come into class, I want you to, as discreetly as possible, and this is for math class, you're sitting down, I want you to take your left shoe off, and I want you to put that shoe, let's say, behind your back. Or under your seat or in a backpack, out of view, so it looks like you just have no shoe. If I walk into class at tomorrow, it'll be a little bit early. I think it'll be 12:25 for third period, and it'll be 10:30 for second period. If I see that you have no shoe on your left foot, then I will give you full credit for classwork, regardless of where you get. If you don't have your left shoe off, then I know I need to not give you full credit, and you can only earn a 4 out of 5 for the classwork. So now, how are we going to deal with the non-squared term? There's actually two different ways of dealing with the non-squared term. And they're actually kind of the same way. So if we take something like ax squared plus bx plus c equals 0, there is a skill called factoring. And that skill, when you factor a quadratic trinomial, it will work. You can either do this or you can't, trinomial. We call it a trinomial because there is 1, 2, 3 terms. The way you factor a quadratic trinomial, if it doesn't work, you force it to factor. And if you force it to factor, you can produce the quadratic formula. So right now, we are going to deal with the easier quadratic trinomials, and that's when a equals 1. Our next unit will be what happens when a doesn't equal 1. But for now, how are we going to factor x squared plus bx plus c equals 0. How are we going to factor? Now let's go back to what we mean. What does factoring even mean? From a mathematics standpoint, when I say list the factors of 72, I want you to write down the numbers that multiply to 72. There's a lot. So let me, what is that? 3 and 24, 4 and 18, 5, no, 6 and I should be able to do this faster, 6 and 12, 7, no, 8 and 9. And now I know we've got them all. These are called the factors of 72. Factors meaning these numbers multiply to 72. When we factor a quadratic trinomial, we are looking for two things that multiply to this quadratic trinomial. So where do we get a quadratic trinomial from in the first place? Well, let's take an example, something you might remember from earlier in the year. What is x plus 2 times x plus 1? Well, some of you memorized in middle school a little acronym for this called first, outside, inside, last. So you may have heard the term FOIL, but that's not an algebraic process. That's just an acronym to help you to remember how to do it. What you're doing when you multiply what are called two binomials together, you're going to take this number and multiply it here. And that's going to give you x times x plus 2 plus 1 times x plus 2. And then you're going to distribute again. And you're going to get x squared plus 2x plus x plus 2. And then you're going to collect like terms. And there's your quadratic trinomial. If you use this FOIL method, you get x squared plus x plus 2x plus 1, which is the exact same thing as this. So I know some mathematicians that really hate the term FOIL, and they hate it because it cheats you out of knowing what's actually happening, which is just the distributive property twice. You're just using the distributive property to multiply two binomials together. So that's why we're going to call this process of undoing that multiplication factoring. We are going to take a quadratic trinomial that looks like this and try to figure out if we can write it into these two numbers that multiply to get it. That's why it's called factoring. So let's just take this example. How would you start with x squared plus 3x plus 2? And how would you get down to x plus 2, x plus 1? Well, I am going to give you the step-by-step instructions that will never fail you. The first thing you do is you look at this number and you list the factors of that number. So you list the factors of 2. The other thing I want you to do is I want you to show me you watched the video by writing a checklist. So number 1, you should say list the factors of the constant. So as we talk about x squared plus 3x plus 2, I want you to write it in general terms of x squared plus bx plus c. So you want to list the factors of c. Once I get the factors of c, I look to find out, is that constant positive or negative? If that constant is positive, I'm going to add factors. And if that constant is negative, I'm going to subtract factors. Now when I say subtract factors, I'm going to subtract these two numbers. In this case it's positive, so I'm going to add these two numbers. 1 plus 2 is 3. I'm looking for that middle number. If I get the middle number, then what I know is that this quadratic will factor. And the way it will factor is I will write an x times x here. That's how I'm going to get an x squared. I'm going to put a 2 and a 1 here because that's how I'm going to get a 2. And then on the third and final thing of the checklist is if this is positive, it's going to go plus plus or minus minus. because the only way to get a positive 2 is to take a positive times a positive or a negative times a negative. Because the 3 is positive, I know what goes here is plus plus. And look, I'm back to that final answer there. So your checklist should look something like this. List the factors of C. If C is positive, add factors. If C is negative, subtract factors, looking for the middle term, B. If it's positive, the signs are plus plus. If it's negative, one sign is positive and one sign is negative. Let's figure out how that works. Okay, what if you get a negative last term? So x squared minus, we'll do minus 5x minus 6. So the first two steps don't change. List the factors of 6. If this term is negative, subtract factors, looking for the middle term. 3 minus 2 is 1, 6 minus 1 is 5. We're going to use 1 and 6 because 6 minus 1 is 5. So now it's x times x. The reason the x goes here and the x goes here is x times x is the only way to get 1x squared. Now 1 and 6 are going to go here because I know 1 and 6 multiply to give me this 6 that I need. I could have put 2 and 3, but 2 and 3 aren't going to work because they don't subtract to 5. They subtract to 1, so it's not those. Now I have to figure out what sign goes where. We could do trial and error, but you can also think about it in the following way. One of these has to be negative and one has to be positive, because the only way to get a negative 6 by multiplying 1 and 6 is if one of them is negative. If they were both negative, you would get a positive 6. If they were both positive, you get a positive 6. So then you look to this sign. And because b is negative 5, then I know I need a negative 6 and a positive 1. When I multiply this out, x times x, x squared, x times negative 6, negative 6x, 1 times x, 1x, 1 times negative 6, negative 6. I know because I made the bigger number negative, I'm going to get a negative 5 when I combine those like terms. If I had switched and had this be negative and this be positive, then I would have gotten a positive 5x, and that's not what I'm looking for. I'm looking for a negative 5x. That was a long video, and I know that was a long video, and I'm sorry, but these are the building blocks of a very important skill in algebra. Your ability to factor a quadratic trinomial when the coefficient of a is 1 is crucial for success at higher levels of mathematics. You've got to be able to break this down into different factors that multiply together. It gets really, and it's not hard, it gets more challenging when we don't have a 1 here, but that's not coming till tomorrow, or this weekend's video. So what I need you to do is watch this video, write down your checklist. Tomorrow I'm going to want to see your checklist for how to factor. After I see your checklist and you have your shoe off, then I'm going to know you're ready to go and you watch the video. Thanks for watching. Have a good night. Peace.